this will be an infinite solution. We know that if you have two equations that have infinite solutions, then they're going to be the exact same line. Their equations are going to look exactly the same, but as we can see here, these two do not look exactly the same. Well, let's say that we decided to use substitution to try to find the solution. Well, we would make sure that one of them is in y equals, well, it is, so we would take negative 5 minus 2x and we would substitute it in for the y in the top equation. So we would have 2x plus not y anymore. It's now negative 5 minus 2x equals 5. So this right here came from y equals negative 5 minus 2x. We just substituted it in. And then we solve. 2x minus 2x. Those are like terms. So we combine them and we know that 2x minus 2x is 0. So we have negative 5 equals negative 5. This is supposed to be a negative. That's my fault. Okay? Alright, does negative 5 equal negative 5? Yes, it does. And if it equals each other, then that means there are infinite solutions and you don't have to do any more substitution. And to graph that, we would of course graph this bottom one. We would start at negative 5, 1, 2, 3, 4, negative 5, go down to 1, 2, 1, 2, and over 1. Alright, so that would be that line. And this one we would have to get it in y equals form. So to get it in y equals form, we would take 2x plus y equals negative 5, and again, that's supposed to be negative 5. We would move the x, and we get negative 2x, and it's no longer there, so our equation is y equals negative 5 minus 2x. We begin at negative 5, right down here where we did, negative 1, negative 2, negative 3, negative 4, right here, negative 5. And then we would go down to 1, 2, and over understood 1, and notice that it's the same line. So we know by graphing that it is going to be infinite solution, but if you come across one where the two numbers at the end are exactly the same, then that's infinite solution. And again, if you come across a problem where the two numbers are not equal, then that's no solution.